It isn't always the case that the theorem we write down about a particular hybrid system will be provable. In some cases, you may have initial conditions or a loop invariant that are too weak to guarantee the property you're trying to prove. In these cases, we can interact with KeYmaera to try to discover or synthesize stronger conditions. Take this simple theorem as an example, where z is the position and v is the velocity of a train. We want to prove that the train does not move beyond a stopping point m if it applies braking force b. However, we've only assumed that the position of the train is initially behind m and have no guarantees about its initial velocity. The property won't prove since the train may be moving too fast initially to stop in time. But all isn't lost. We can always load this property into KeYmaera, try to prove it, and see what it gives us as open goals. Some of the open goals are going to be useless. They'll just say, well, I would be able to prove it if only I could assume a contradiction to my current assumptions. However, if you look through the different cases, you may be able to find one open goal which has a more interesting property, one that doesn't just contradict the initial assumptions you've already made about your property. You can right-click on this formula and then copy it to the clipboard. Then, editing your file, you can add it to the initial conditions that you already have. Now we can reload the file into KeYmaera, and we'll see that this property is now added to the initial conditions. And when we click Start, the property proves. Since this formula has been returned by the quantifier elimination algorithm, it may look a little bit strange. But we can rewrite it and see that it's just the distance between the train and the stopping point is greater than or equal to the standard stopping distance derived from regular kinematic equations.